All right, I want to welcome Hononegah, Algebra 1, and I want to apologize if you are watching this video for a second time. I had to redo this video, so again, I apologize. So here we go. Algebra 1, Section 3.1. Today we're going to talk about function and a relation pair inputs and outputs. When a relation is given as an ordered pair, the x-coordinates are the input, the y-coordinates are the output. So again, we talk about a little bit of an xy chart. Now, this is very important, and I'm going to write this down. Anytime you want to say something is a function, one of the two explanations that we will accept is that each input has one output. So if you want to say that something is a function, that is one of the two explanations that you're allowed to give. So again, so as we go through this, if you want to say something is a function, that's your reason. Now, this is anytime you're talking about a function, there's lots of different ways to do it. An equation, input, output, words, graphs, ordered pairs, mapping. And so who has a job of babysitting and mowing grass? So let's say you get $10 for mowing grass. So if you mow one lawn, you're going to get 10 bucks. You mow two lawns, you're going to get 20. You get three lawns, you're going to get 30. And again, that is a function. So every time you mow some grass, then you'll get paid more money, ... As you're looking at the first one, -2, 2, -1, 2, 0, 2, 1, 0, 2, 0. Deciding whether or not something is a function. As you are looking at all the x values, and I would repeat the x values only, is there ever an x that has two different y's? And the answer to that question is no. So this is a function. The fact that -2 goes to 2 and -1 goes to 2 doesn't matter. So the fact that the x values go to the same y doesn't make any difference. And the reason you would say is exactly what I put previously. Each input has one output. So what I tell my classes is a little hint is to look for the double x. So like you have 4, 0 and 4, 3. So that is not a function. And now I will accept one of two reasonings. One, you could actually just say 4 has two outputs. So you called it not a function because one of the inputs has multiple outputs. Or you can repeat what you did previously and just say each input does not have one output. So again, I'll accept either one of those. You do not have to do both. Next one. These are the same thing, just written in a different way. This one's a table. Notice, again, you're looking for that double x. So this is not a function. And my reason is because 0 has two outputs. Next one. This one is a function. Now, remember, it doesn't matter if an x value goes to the same x or y value as another one. That makes no difference. Each of the inputs, each of the x's, has one output. Next, we're going to talk about what's known as the vertical line test. The vertical line test basically states that if you have a graph and you draw in a vertical line, you will hit only 1 point. So if I draw in a vertical line, I'm only going to hit 1 point each and every time. This makes this a function. Now, the reason, remember I said there was two reasons. This one is because it passes what's known as the vertical line test. Now, I'm going to let you abbreviate that to vertical line test. Next one is not a function because it hits more than 1 point and therefore fails the vertical line test. So again, if you have a graph and you want to say something is a function, it passes the vertical line test. So in this picture, notice I draw in a vertical line right here. I hit two different points. That is not a function. And the reason you would say is because it fails the vertical line test. The next one is a function. And again, reason you would say passes the vertical line test. C, again, anytime I draw in a vertical line, I'm only hitting 1 point, so therefore this is a function because it passes the vertical line test. Next one, pretty obvious. I hit 2 points anytime I draw a vertical line, so therefore this is not a function because it fails the vertical line test. You try, so I'll go ahead and hit pause for a second, and you can try these. All right, I'm back. The first one is not a function. So it's not a function, and the reason is because 5 has 2 outputs. You can't just circle the ones that you're referring to, even though I did. This next one is a function. And again, the only reason that you would say is each input has 1 output. A half goes to 3 different numbers. That is not a function. And again, the reason would be because a half has, in this case, 3 outputs. And again, you're only allowed 1 if it's a function. Next page is also a you try, so go ahead and hit pause again. And I'm back. So the first one is a function. The reason why is because it passes the vertical line test. Next one actually is a function. A lot of people in my class messed that one up. Again, if I draw in a vertical line, I'm only going to hit 1 point because it passes the vertical line test. And the last one I hit two points, would be not a function because it fails the vertical line test. So I'm going to go off script here for just a second and make sure everybody is aware of this. So I'm going to make myself a blank sheet of paper. If you want to say something is a function, there's only 2 reasons why. 1, each input has 1 output, or it passes the vertical line test. Those are the only 2 reasons that you can say that something is a function. If you're going to say something is not a function, then you're saying the not for those. So those are the only 2 reasons that you can say something is a function. Next, now, domain and range. Domain is always basically your input values, or what's known as your x values, or also what's known as your independent variable. The range is your y values, or what's depending on something. Now, when you talk about independent versus dependent, independent basically means that that's what you're putting the numbers into, or that is what you are actually doing. The output is what you'll get out of it after. So in this case, like the little machine here, your input is a -2 and your output is -6. This would be your domain. This would be your range. All right. Now I'm going to tell you something that's ultimately not talked about until the next lesson, but I really think it should be in this one. Discrete versus continuous. If I have something that's discrete, that means that it's disconnected or individual points. If you have something that is discrete, label all the points. So I have the point -3, -2, -1, 0, 1, 2, and 3, 4. If you have a discrete situation, the domain is always the x values of each point, and the range is always the y values of each point. So in this case, the domain is -3, -1, 1, and 3. The range is -2, 0, 2, and 4. Order does not matter in this. So again, if you have a discrete situation in which you have individual points, the domain is the x's and the range is the y for each point. So I'm going to go ahead and go down here to C. Okay, so I see a discrete situation. So this is the point 1, 5. And this would be the point 3, 5. This would be the point 4, 2. And this is the 6, -1. So again, this is discrete. So the domain is the x values of each point. So 1, 3, 4, and 6. The range. Now, 5 and then there's another 5. I do not need to repeat it. I won't count it wrong if you state it twice. So if you accidentally put a 5 again, I would just cross that off because it's, again, unnecessary to state something twice. So that is discrete points. Next is what's called continuous. Continuous means that it's connected. So you'll notice that the points in this graph are connected. Here's what you're going to need to do if you have a continuous. You'll need to find the furthest point to the left, and then you'll need to find the furthest point to the right. You'll need to find the lowest point and the highest point. Well, in this particular picture, the lowest point is also the one on the left. Here's how you're going to do domain and range. The x values. Basically, the x values are between the furthest point to the left and the furthest point to the right. So the x values in this case go from -2, which is the smallest value on the left, and 3, which is the highest value on the right. You'll do the same thing for y. So the lowest value of y is -1 down here at the bottom, and the highest value of y is 2 all the way on the top. So now I'm going to give myself a little bit more space. They actually label these points for me already. And so now domain and range. This is continuous. Now notice that the 1, 1 is an open circle. So when I go to use the 1, I'm not going to put an equal to line underneath it. So the smallest value of x is 1. The largest value of x is 4. For the y's, the smallest value is 1 again, and the largest value is 7. So for continuous graphs, you're basically going to have an inequality. For discrete graphs, you're going to have individual x's and individual y's. So let's do the next one. This is a U-try, so if you want to hit pause for a second and try it yourself. And we're back. So -2, this is a discrete graph. So -2, 4, -1, 2, 0, 0, 1, 2, and 2, 4. Since it is discrete, I need all the x values. So -2, -1, 0, 1, and 2 would be all the x values of the discrete points. The y values then for the range, 0, 2, and 4. Notice that I did not repeat any of the numbers, but you could. I won't count that wrong if you repeat the 2 that happens twice and the 4 that happens twice. Now we have a continuous graph. We have the point 1, 4, that's the furthest to the left. We have the point 5, 4, which is the furthest to the right. And then we have the point 3, 0, which is the lowest point. So now the domain and the range. Domain is the x's. So the smallest value of x is 1, and the largest value of x is 5. So furthest to the left and furthest to the right. The next one, the smallest value of y is 0, and the largest value of y is 4. It happens to occur twice, and that's not a big deal. Don't worry about that. Next, independent and dependent. Again, the statement y is a function of f means that y is depending on x. What I talked about previously, when I am plugging a number in for x and getting out a y, that makes x the independent variable and y the dependent variable. So now I've got a word problem. The function y equals -3x plus 12 represents the amount of y in fluids of juice remaining in a bottle after you take x number of gulps. Identify the independent and dependent. So the independent is the gulps, and the dependent is how much fluid is left. With that being said, they're giving me a domain, and this is discrete, by the way. So no gulps, 1 gulp, 2 gulps, 3 gulps, 4 gulps. So I'm going to plug 0 in for x. So -3 times 0 plus 12. So -3 times 0 plus 12 would be 12. I'm going to plug 1 in. So -3 times 1 plus 12. -3 times 2 plus 12. And so on. So now I'm going to take 1 gulp, 2 gulps, 3 gulps, 4 gulps, and I'm done. I'm out of juice. There's 0 left. So what is the range? Well, it starts off with 12, and then there's 9, and then there's 6, then there's 3, and then there's 0. So the range, again, is the y values in the problem. So the domain was given to me, or the x values in the problem were given to me. Last one was about heating up a oven. The function temperature, T equals 19m plus 65 represents the temperature of the oven after preheating for m minutes. So identify the independent. So the longer I allow the oven to heat, then will depend on what the temperature inside the oven is actually going to be. Now the recipe calls for the oven to be 350 degrees. So a temp of 350. Let's find the m then. So I'm going to subtract 65 and get 285 and then divide by 19. So m would equal 15. So 15 minutes for this oven to get to 350 degrees. Now, would you think this domain and range would be continuous or would it be discrete? Well, it's continuous because the oven goes up, it keeps going up little bit by little bit. It's not a situation in which 1 minute and then it jumps 15 degrees the next minute and then it jumps 15 degrees. It's not instantaneous. So it's continuous. Now, on a test or a quiz, we're not going to ask this question to actually give me the domain and the range, but that's what I wanted you to just describe it. And so I'm going to actually do the domain though. So the x values, or in this case, the minutes. So if I don't turn the oven on at all, to 15 minutes when it actually gets to 350 degrees. The temp, now this is an interesting one. When I plug 0 in, the actual temp inside the oven is 65 degrees, and I want it to get up to 350 degrees. So that is the domain and the range. Again, we're not going to ask that question necessarily on our test or a quiz. Homework assignment. It's a book assignment. And again, if you are watching this video for the second time, I apologize. But again, I was hoping to get some explanation then for each of you. So good luck.